This video is for our 12.4 homework. So if you have any questions on these problems, be sure to follow along. So number one tells us that we have this floor plan for the house and we've got our vertical lengths, so up and down, and we've got our horizontal lengths given here. What is the floor area in square feet? So there are several ways that we could cut this up. So we could cut it across here. So we could go this way and find this one big rectangle and this two smaller ones. We could also just cut it this way and find each of these three pieces here as well. So I'm going to just leave it like this. If you want to try it a different way, you are welcome to. So we're going to start over here. So we can see this distance from here to here, looking up here, is 20. And then from here to here is 24. So we need to do 24 times 20 to find this first box here. So this is our first section of our house. Okay, then we'll do this middle section here. And this length is 24. And then our height on this one, so from here all the way down. So we need to put all of these together. So we need to do 24 times, we've got 24 here, and we've got another 8 up here. So we're adding on 8, and then another 8 down here. So first we need to add these up to find that entire floor, and then times it by the width, which is 24, to find the second section here. And then our third section, the base is 28. So our third section has a base of 28, and then a height, this is the same as this, which is the same as this, is 24. So we're going to do all three of these problems. So first section, second section, third section. And then we want to add our answers together. So whatever these equal, we want to add these all together to find our total area in square feet. Number 2 tells us that on a baseball field, home plate is where the batter stands to hit and where a runner scores a run. What is the area of the home plate diagram shown in square inches? So they cut it like this. So I know there's this other dotted line, but it's really just showing us the height of that. We've got this triangle here, and then we have this rectangle here. So let's start with our rectangle. So the base is 17 and the height is 8.5. So 17 times 8.5, and we're going to add on. So we want to do this first, and then we're going to add our base here. Let me switch over to another color. So we've got this line here is the same as this one. So now we're taking 17, that's the base, and our height goes straight up and down. And we're going to times by the height. So these are exactly the same, except for this one's a triangle, right? It's missing all of this extra stuff out here. So we've got to cut it in half. So we're going to do each of these problems. So this will find the rectangle. This will find our triangle. Then we add our pieces together to find the area of the home plate in square inches. Number 3 says that Kirsten wants to buy wooden flooring for her bedroom. This diagram shows the bedroom shape and dimensions. So it's not quite a rectangle. So we can cut it up and down, or we can just do this big one and then this little one. So let's do that. So let's just keep that big one there and then cut it straight across and find this little one up here. So then it goes on to tell us that one case of flooring covers 25 square feet. It wants to know how many cases does she need to buy. So the first thing we need to know is how much area is in her bedroom. Then we'll see how many cases she needs to buy. So let's start with this bottom rectangle here. So the base of this whole thing is 14. And then our height is only this section here. So I know I'm drawing by the number 10, but 10 also includes this. We only want this part here. So how much is just this part right here? It's 8. So we need to do 14 times 8 to find the bottom rectangle. And now we're going to look at this top part here. So I can see that the width is 8. So we're going to add on. So we're doing this first. And then we're going to add on 8 times something. So we need to figure out this missing dimension here. So we know this whole entire thing is 10. And this much is 8. So from here to here is 8. How much more do we need to get to 10? 2 more. 2 plus 8 is a total of 10. So this section is 8 times 2. So here's this rectangle. Here's this rectangle. So we're finding up both of our rectangles and we're adding them together since it's one composite shape here. So once we have our area, so this is our area, we can know that every time she buys one case, it's going to cover 25 feet. So she'll cover 25 feet. So we want to take our area, whatever this answer is, and we're going to divide it by 25. And the quotient up here is going to tell us how many cases of flooring that Kirsten needs to buy. And if she has leftover floor, she's got to buy an extra case. Otherwise, she'll have a little area of her room that has different floor than the rest of it. So make sure she has enough to cover the entire floor. So she'd rather have a little extra floor left over than leave part of her floor without the new wood floor. Let's go ahead and finish number 3. Number 4 tells us that Robert is designing hexagonal tiles that are made up of 12 identical right triangles. So we can see that we've got all of these identical shapes here. So this, even though they're different colors, this blue one is the same as this orange one, right? We can see they're both have the same height. They have the same width. Their angles are the same. So even though they're different colors, all 12 of these triangles are the same. So which equations can Robert use to find the area of this hexagon in square centimeters? So we need to remember we have 12 triangles. So let's ignore that 12 for right now. Let's just look at one triangle. Let's look at this blue triangle right here. What is the base of the triangle? It's 3. So we know, right, to find one triangle, we want to do base times height, but then we cut it in half. So the base is 3. So we're going to do 3. And then the height straight up is 4. And then we'll cut that in half. That's going to tell us one triangle. This is one triangle. How many triangles do we have? Well, we have 12 of those exact same things. So once we know what one triangle is, we want to multiply that by 12. So let's go ahead and find the area of this hexagon here. So 3 times 4 is 12. So base times height, then we want to cut it in half is 6. So this triangle is 6. That means every other triangle is 6. 6 times 12 is 72. So we want to look at these equations and see which of them are telling us the same information. So we come here and we do parentheses first. So we still need to follow our order of operations. So we do our groups first. 6 times 4 is 24. So now we have half of 24 times 6. So we don't have any exponents, so we need to multiply. Well, half of 24 is 12. 12 times 6, 72. So this works here. So they took 2 triangles together to get 6 here. They did 6 times 4, and then they said we have 6 orange and blue groups. So that one works. So parentheses first, 3 times 4 is 12. 12 times 12 is not 72. So go through each of these and solve each problem and see which other ones equal 72 because we want to choose all of the equations that could get us this same area here. Number 5 gives us this figure here. So 6, 11, 4, and 7 as the top. Which equations, so again, more than one, could be used to find the area of this shape? So let's start and find the area. So let's cut it up and down for this one. So my base for this part. So I know this looks like it's 11, but right, we cut that. So it's only 7, and this part is 6. 7 times 6 is 42. And then this part, we've got 4 here. We need to find this section here. This whole thing is 11, and this much is 7. 7 plus what is 11? 7 plus 4, so this section is 4. 4 times 4 is 16. We'll add those together. 42 and 16 is 58. So we're looking for any of these that are equaling 68. So let's write down, we did 6 times 7, and then we added on 4 plus 4. So here we can see 7 times 6 and 4 times 4. So there's one that equals 58. So on this one, let's see, they did 6 times 11. So they found this entire thing, and then they took away this piece, which is 4, and this section is 2 right here because 4 plus 2 is 6. So this one works. So I want you to go through and see if you can find any other ones. So this one did 4 times 11. They did this part. And then see if they did the other part to equal, what did we want it to equal? 58. So go through and see if any of these other ones equal 58. Number 6 gives us this figure, and it wants to know the area. So it looks like this section here is missing. So I'm going to find the entire thing, and then I'm going to take away that triangle. So here we have the whole thing is a rectangle. The base of the rectangle is 16, and the height of the rectangle matches this one here, 8. So we're going to do 16 times 8. And then we want to take away this triangle. So the base of the triangle is 8. The height of the triangle is 4. But then we have to cut that in half. So we found our rectangle, we found the triangle, pull the triangle out, gives us your area in square meters. Number 7 has this 5-sided shape here. So I'm going to just cut it straight across. So I have a rectangle, and then I have this triangle here. So we've got our base, we have our height. So this problem here is 8 times 2. And again, this base is 8 and the height is 2. But then we want to cut it in half and then put the rectangle and the triangle together. Okay, number 8, you can totally do it. It's a multiplication problem. Don't forget to move your decimal the correct number of places. Hey, and number 9 today wants us to write 12/15 as a decimal. So there are lots of ways that we can do this problem. I think the easiest way is to say I have 12 and I'm dividing it by 15. So go ahead and add a couple zeros here. Do 15 into that, and that will tell you what 15 is as a decimal. Hey, if you need any other help on those problems, please let me know and we can set up a time to meet together.